Internal voice. Actually, oh my God, sorry. Again, I'm introducing myself. Welcome to my Whitey world, to my Whitey channel. This is again, I am a senior internal voice. This is Sotero. Oh my gosh. Okay. So, I'm done with immunology topic during my live streaming and vlogging last 2 days ago or last 3 days ago. Okay, and now we'll be able to do another topic for this live stream. Okay, actually yesterday I have a very weak signal that I cannot proceed to the live streaming. What I did is I able to make videos, and then after that I will be able to upload it in the way to change it. So to say, those videos are not yet processed completely. So I am very eager and willing to have this live streaming because live streaming can be uploaded very fast compared to the videos to be uploaded in YT channel. Okay, that's the essence behind live streaming compared to the plugins. I'm making vlogs on. Okay, so this is immunology. So I discussed a lot. Actually, there is one also part one of this enzymology, right? Yesterday, but the quality of the sound is very bad. Then I did not also discuss some important, information regarding enzymology. I forgot also to discuss some. Okay, then I forgot also to show uh, different examples of an enzymes, how they function, how they behave. For example, in the digestive system, like that. I forgot to to stress out or discuss for that particular enzymes. Okay, now we shall put this in this way. Okay, these enzymes really are very important and essential to help speed up and catalyze. Oh my gosh, the microphone is feedback. To catalyze the reaction to produce important and essential biological substances in order to boost and improve our healthy immune system. Okay, so this will help become us healthy. Okay, because most of the biological and physiological chemical reactions inside our body, okay, so I mean the micromolecules, the macromolecules, so those are biological substances, right? And then they perform chemical reaction inside our body. So they will not fulfill or achieve a complete chemical reaction without the aid of these enzymes. Okay, so it really needs an enzymes to activate the chemical reaction. Okay, something like that. So how do we know that we will be up there? So of course we need to experience that we are removing our waste, something like that during urination, like that during sweating, something like that. Okay, during what do you call that one? Bowel movement. Okay, like that. So it will be released, something like that. So if there's no proper and effective metabolism cycle, that means also that our enzymes are not functioning properly. Okay, because of course we cannot deny that those enzymes are made up of usually or 90% of made of protein. Okay, protein-based catalysts that speed up or catalyze the chemical reaction without being consumed and used up, okay, through the entire chemical reaction, something like that. Okay, meaning it will never be consumed, it only used to aid the chemical reaction, just like a catalyst in inorganic chemistry. But I need to point out that there's a little difference between a catalyst and an enzyme, okay, in different context, okay, of the discussion. For example, catalysts used to speed up also the chemical reaction, right? But it's usually applied in different chemical process industries. For example, producing of petrochemical products from petroleum-based raw material, which is specifically the crude oil. Okay, a lot of chemical processes, physical and chemical separation processes will be there. And one of the example there is the catalytic cracking. Okay, catalytic cracking meaning to crack larger molecules to produce various molecules that is or that will be our products. Or for example, from crude oil, it will be gasoline, diesel, kerosene, and a lot of fuel gases. Those are the products coming from the crude oil. So before coming to products, there's a lot of processes. And those processes really need the catalysts to speed up the reaction. Okay? So a lot of irreversible reactions observed in a process. Okay, irreversible, meaning it will never go back to its original reactants after the chemical reaction. So usually these catalysts are applied in irreversible reaction. Okay, God created only few. We can count only those ideal perfect reaction. Those are reversible reaction. For example, I'm taking a very, very basic example. The reaction of hydrogen gas plus oxygen gas will produce 2 moles of water. So this is God-given perfect and ideal chemical reaction, reversible reaction, because if you try to reverse that one, the product will go back to its original state. Something like that. In that situation, we don't need a catalyst to speed up the rate of chemical reaction. It will just automatically yield a product, water. Okay, something like that. And we cannot also question God's power and magic and miraculous activity. Because imagine you are adding a gas to another gas and it will produce a water or a liquid. How come? Okay? This is an exemption for other chemical reactions. Imagine there are 3 phases of matter: solid, liquid, and gas. Technically and scientifically, if we add solid plus solid, our product will be solid. Okay? Without question, technically. If we add liquid plus liquid is equals to liquid. But why God created a gas plus gas is equals to water? Okay? And until now, it could never be explained from our scientists, even up to this point in time. So meaning to say, God is powerful than those scientists, because there are things that we cannot justify through scientific research and scientific explanation. Again, gas plus gas is equals to water. How come a gas reactants will produce a liquid? Okay, and we drink that every day. Okay, like that. Okay, so very, oh my gosh, this breaks the rules of chemistry. Now, it will just again go back to a gas. When you heat the water, it will evaporate, okay, it will vaporize and undergo the heat of vaporization during evaporative cooling, something like that, okay? Heat of vaporization, meaning to say the quantity of heat required of a 1 gram of a substance to change into a vapor state or a gas state from a liquid. So undergoing the process of boiling point, something like that. When it reaches 100 degrees Celsius. Okay, something like that. So imagine hydrogen is a gas, oxygen is a gas, then it produces a liquid water. How come? Okay, so this is technically breaking the rules of chemistry, and even our scientists cannot discuss up to this point in time. Okay, so that's an example also. I posted that in my Facebook account before, and nobody gets the answer. Okay, because I posted that there. Give a chemical reaction that you add a gas. It's also difficult to state an example, but I forgot the basic chemical reactions is only the water chemical reaction. H2 plus O2 is equals to 2 moles of water. And we can reverse that perfectly and add without adding a catalyst. Okay. Now, that is a catalyst in the process point of view. Now, we try to understand catalyst in biology and combination of biology and chemistry. That is biochemistry, right? Okay, this catalyst or the enzymes, you cannot apply the enzymes in the in the process because that's physical processes. So enzymes as a terminology will be applied only in the physiological reaction in our anatomy structure inside our body. When you mean of anatomy, that means developmental organs inside our body, the brain, the kidney, the pancreas, the intestines or the gut, the GAT means the small intestine and the large intestine, something like that. The respiratory system or the lungs, the reproductive system or the excretory system, something like that. Okay, those are anatomy. We study that one, that is anatomy. That means the structures of developmental organs inside our body, something like that. And we speak about physiology, that's meaning studying of the behavior of how these organs react when certain substances could be a biological or chemical substances. Now, in those chemical and biological substances, we will not speed up the rate of chemical reaction without involving these enzymes. This is very important. So, meaning to say, in direct conclusion, we will not become healthy without these enzymes because this really triggers to speed up the chemical reaction in order for us to receive nutrients, vitamins, antioxidants, vitamins, carbohydrates, sugars, fats, lipids, steroid hormones, nucleic acids for DNA sequencing, okay, RNA, ribonucleic acid for genetic information, something like that, and all other both macromolecules and micromolecules that has been studied in biochemistry. Okay, something like that. So if you learn about biochemistry, you need to have an adequate knowledge of biology also. That's why most of the BS chemistry graduates and BS chemical engineering graduates, it's very easy for chemistry because our cells will really behave and functions knowing that foundation of atomic theory, something like that. Okay, so that's very, very basic. Okay, now if we speak about enzyme, meaning that it's also a catalyst. Okay, it depends only for the application for our discussion. Since my discussion here is more about on biology or biochemistry, so I will not use the term catalyst, I will use the term enzyme. But remember, these are all substances that will speed up or catalyze the reaction so that we have a complete chemical reaction, something like that. Okay, this is very clear. Now we proceed to the enzyme. Oh my gosh, it's a very long introduction, right? Actually, that is no longer an introduction, by the way. Okay, so forgive me if I talk so fast that's on the spot, right? Everything that comes out from my brain is I'll be able to share to everybody in combination with my staff knowledge regarding sciences. Okay, and it's very enjoyable to dig up regarding health science, right? Health science is very good because it teaches us to be healthy individual. Then, of course, every individual has its own goal to survive in this contemporary world. Contemporary world, meaning to say, so nobody wants to die early, of course. Am I correct or not? Nobody wants to die early. Everybody wants to survive for life sustainability. And how can we do that? We can do that by not abusing our health. So how can we do that by not abusing our health? We should be observant to all the foods and drinks we intake into our body. Meaning to say, scientifically, we will be able to administer adequate in combination with good exercise, good sleep, something like that, and any physical routine that will boost our immune system, something like that. Okay? And we will be smart enough to do that so that we will try to prevent any diseases that will come in the future, because in reality diseases and sickness will come at an age of not depend on that, because we really have our own responsibility. And how can we do that? Okay, we can do that by self-discipline. Self-discipline for all the substances that we will be able to intake in our body. And especially, I will not push you to study epidemiology, right? this is discussed in epidemiology, a branch of medical science that deals with the study of the control and the prevention of ill health diseases and sickness. That's all about epidemiology all about. In combination of epidemiology and health science, okay, we can really have the knowledge how to prevent those diseases. Could it be an acute diseases or a chronic diseases? Okay, it doesn't matter at all as long as we prevent them, because prevention is better than cure rather than treatment and cure. Okay, how can we do that aside from self-discipline and the correct selection of the healthy foods and drinks? We need also to study, explore, read information in the social media world. Okay, and we should research a lot of science reference materials or any trivia regarding health science, and we'll be able to learn something in order we can prevent those diseases from coming in. Then we will not be able to spend more money in going to the doctors and hospitals, because we are trying to, especially we are not forever working. Okay, if we will reach the age of 60 years old and above, then we will not be working at that time. So how can we have money for that? Okay, so good only if you have huge savings in our bank accounts. But what if we don't have money at that point in time? So we need to security in the future, and we ourselves must be responsible enough by not abusing ourselves. Okay, and this information is very important. Okay, so it all starts with an enzymes. Okay. Oh my gosh, I have my breakfast here. The selection of my breakfast is just very easy, quite simple. I have the oats here, plus I cheat. Sorry guys, I cheat because if I never cheat also, okay, I will never feel satisfied. Sorry, because this is only a minimal on, what is called a chicken nugget. A round shaped chicken nugget, something like that, that I bought in a market, something like that. And this is only 1 piece. So meaning to say, I administer the intake only in a not in a frequent manner, in moderation. Okay, okay, this is only good for those people that having the weight loss program. Okay, if you don't have the weight loss program, then don't do it. Okay, I'm literally meaning this is for the weight loss program. Since I'm maintaining my weight loss program, then I eat high fiber foods, high wheat foods like that. Okay, I stayed and totally eliminated white rice on white bread. Okay, I don't want to add sugars day by day in my menu. What if you don't do the exercises and physical activities? What I exercises is that every day you have to sweat. It's not enough you don't have sweat, because sweat is a composition of lactic acid, propionic acid, something like that, 80 to 90% water, a lot of electrolytes, calcium, magnesium, or electrolytes or salts. Okay, plus the toxins. Toxins meaning non-identifiable, unless you will bring those samples in laboratory so that you can determine what kind of toxins are being released in your body during exercise. But I am pretty sure that we have the propionic acid. What is propionic acid, Sotero? That is body odor. Okay, the formula of body odor is a propionic acid in organic propionic acid. Okay, and we have also the lactic acid. I don't have to state the formula of that because our discussion mainly focus on an enzymes. Okay, I'm just telling you that we need to sweat it out so that we will become healthy and remove the sugars from our body, because we have a lot huge sugars in our body. Okay, something that we will also use up our ketosis sugars in our body. Right? So we should always keep adding a refined sugar or processed sugars in our system day by day. Okay, that's not good. It can develop type 2 diabetes. And insulin hormone is very expensive nowadays, to increase the level of our insulin hormone to regulate the added, okay, like that monosugar and simple sugar occurring in our bloodstream, something like that, in order for us to become healthy. Okay, this one. Sorry for that analogy. Oh my gosh. So this topic really is very lengthy because you have to connect all the biological substances and the chemical reactions like that. And it's not enough to have also the reactions. Then you have to understand really the behavior of these enzymes. Okay, my gosh. Okay, why talking to Mr. Sotero? Okay, we will go back first to the basic definition of an enzyme. What are the requirements in order for these enzymes to behave and to function effectively and properly? Okay, something like that. Okay, so introduction. Oh my gosh, the introduction was lost. What's happening? Okay, enzymes are those protein-based catalysts that will speed up the rate of chemical reaction or catalyze the rate of the reaction. Okay, that's one requirement. Okay, now it needs an activation energy. We should lower the activation energy so that these enzymes will function effectively and properly. Meaning to say, we need to lower the activation energy. So, what is really activation energy? So, from the words itself, activation meaning to activate. So, what energy is responsible for activation? Okay, think of a kind of energy that activate, okay, in any motion like that, whether in our body or in a motion, whatever motion, that is a kinetic energy, no other. Okay, basic foundation in chemistry or physics, that is kinetic energy, usually involves in motion. Why I say this? Because inside our body system, there's a lot of motion there. They are dynamic. Okay, there are biological substances and chemical reactions there, dynamic, meaning to say they move seconds to seconds inside our body to produce the desired healthy macromolecules and micromolecules so that we as an individual will become healthy. Something that's really kinetic energy is there. Okay, and this kinetic energy needed by the enzymes. Okay, so this activation energy definition, if you have a notebook or what, jot down, then for important key point. My tongue was strong. Okay, this is the power of having live stream, not scripted. Okay, I really love to do vlogging, not scripted. Okay, not prepared because I feel not perfect because I need to correct the mistakes in that situation. I learned something also, and then it's really very interesting, okay, and exciting to do the vlogging and live streaming in an on-the-spot manner. Meaning to say extemporaneous or spontaneous, meaning you don't prepare anything and then you one by one, two, three, four, like that, very systematic and perfect. So that's why others YouTube content creators are doing, but I'm not doing that. Okay, I really need the on-the-spot making of my YouTube content really. Okay, as a small YouTuber and as a newbie YouTube content creator, I love doing this on the spot. Okay, not in preparation. That's why sometimes my tongue will be turned, okay, something like that, and sometimes I mess up with terminologies, and then I can always recover after 2 seconds, after 3 seconds, blah, 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 blah. Okay, going back to activation energy. This is the amount of kinetic energy required to start the chemical reaction. Okay, take note, to start, meaning not to finish. Okay, to start the chemical reaction. So meaning to say, prior to the initial stage of that chemical reactions inside our body. Okay, if we take this in a brief definition, okay, this is an amount of energy or an energy needed to start the reaction. It's simple as like that. So for example, in different science examination, there's a question there that states, okay, blank is an energy that starts the reaction. So the choices will be A, potential energy, B, chemical energy, C, mechanical energy, D, electrical energy, E, kinetic energy. Your answer will be kinetic energy because that is an energy derived or through movement or an energy derived through motion, meaning there's a movement. There's a distance of Newton, Isaac Newton, okay? Okay, we have the three laws of motion, right? The first law will be the law of inertia. The second law will be the law of acceleration. And the third one is the law of interaction, right? We are here in the second law of Newton, of laws of motion. Okay, meaning F is equals to M times A, meaning force is equals to the mass of an object times the acceleration, something like that. And always acceleration derived with acceleration due to gravity, something like that. The constant for that is 9.81 meter per second squared. And bingo, we can really obtain the value of our force. And then after that, we can substitute that in our kinetic energy formula also. If you can still remember, okay, we have the formula of kinetic energy, right, in ideal gas law. Okay, you remember that one? In the PV and RT, then we will be able to insert the intermolecular forces reaction, and we can derive a new formula that involves kinetic energy. Okay, those kinetic energy, we will apply that here in the enzymology, because really we need that to lower the activation energy. Okay, now I need to state this. Okay, if the chemical reaction is ideal and perfect, for example, I mentioned a while ago, God created the H2 plus O2 is equals to water. Okay, like that. That is an ideal and perfection. We don't need, okay, we don't need any activation energy for that, because it's automatic to yield a water, 2 moles of water. Meaning to say, that's already perfect reaction or reversible reaction. We don't need a catalyst for that, because the requirement of a catalyst, we should need to lower the activation energy. Then in that situation, the activation energy is already sufficient and adequate enough to yield ones are not needed in that situation. Okay, so there are cases like that, but only few. We can only count few. But most or trillions or billions of chemical reactions always irreversible reactions. Okay, the products will produce another way products, and this way products will produce another products, and then residues in the air, something like that. And each stage would really need a catalyst or an enzyme. Okay, something like that, to speed up the rate of reaction to yield those desired products that we're trying to obtain in our laboratory testing and analysis, something like that. Okay, so that's very clear. Okay, we need to lower the activation energy, something like that. Now I need to draw a graph and illustration, the relationship between the rate of the reaction and the activation energy, something like that. Oh my gosh, I have no pen here. Later. This is the saddest part of my live streaming, because all of the content are consumed. They're consumed already, the ink. Okay, my gosh, how can I do this? My gosh, it's better to live stream and vlog if I have the software for the animation and creativity, something like bang bang in the screen like that. So it's very new. Until now, I'll have my traditional and conventional way of vlogging and live streaming without those high tech animation or 3D motion of graphics on the screen, because I'm not really a computer expert to do that. I don't have time to really research and download some softwares for that. I think I can do that also, but I don't have time to explore for that. That's why I keep on vlogging live streaming in a traditional and conventional way. Something like that, and it looks like boring. Something like that. Not really looks, it's really boring, but what can I do about it? I love really to do this, to share information, because I develop more on the content, okay? I did not have the goal to develop more creativity and innovation with regards and with respect to new technology. I'm doing this just like, conventional, traditional instructors and professors in the institution or universities, just like that, plainly discussion, plainly talking, sharing information, something like that. Okay, my visual aids usually the pencil pen, ball pen, the black sheet of papers, the microphone, something. Okay, my pure voice, mini pure voice. Oh my gosh, what's new? Okay, like that. That's easy. Now I will try to draw. Oh my gosh, I wish I could have my whiteboard here in the wall. so that they can discuss properly. There's so many knowledge, no, not really so many. There are also some relevant information in the brain retained, but I cannot really share up to this point in time because it's only limited, right? I don't have to live stream all the time, okay? Like that. So what time is this? Okay, I think minimum of 1 hour, maximum of 2 hours, something like that. It will never reach 3 hours beyond. It's also very, very boring. I have to do also another thing for my lifestyle and also to my personal, happiness, something like that. Okay. And then communication to lower our thought. Okay, like this. I have to communicate with him day by day also, something like that. Okay, a lot of things to do inside my room. That's why I don't have time to go outside. Okay, like that. But most of the times, exploring, researching information, whether it is an old information, a new information, okay, that arrives day by day. Okay, something like that. Because science is a scientific research. Okay, day by day, seconds to seconds, minutes to minutes, there are a lot of new science information. It's because science is really undergoing the series of experimentation or scientific research. We don't know tomorrow there will be a new element discovered. Okay, and we don't know after 1 month there's another planet that will be evolving, and then there's another scientist who will discover that one. So really, we don't know really what's all about. Okay, so that's all about science. It's unpredictable. Something like the scientific research. Okay, like that. So that's why we need to have new information. Okay, so since myself love science a lot, so I focus on science because there are also other people who love political issues. There are also a lot of people who love sports, athletics, something like that. So we have our own likes and interests of what topics and information we will be able to learn. Okay, it depends on the individual preference. Okay, but for me, I really love health science, really. Okay, and then in combination of naturally English, I love English so much. Okay? As I kept on talking a while ago, English subject and science are my favorite subjects, something like that. And take note, you need to have a comprehensive knowledge of English because most of the examinations are interpreted in English language, especially international examination or local examination, something like that, or really the PRC board examination, college and university entrance examination, okay, company entrance examination or whatever, it is stated in English in universal language. Then you have to understand the content in that English communication, English comprehension. That's why not really to be boastful and arrogant. If you are good in English, then you have a great potential to pass the examination. Okay? Because all of the questions will be interpreted in English, especially problem solving. And what is really, a mystery of those questionnaires, okay, or questions, you try to use terms and other terms so that the students will be confused. Sometimes they'll trick you out. Then if you don't know the synonymous terms, and the other students will very difficult to determine what's the meaning all about. For example, solubility and then concentration, like that. Sometimes it will use interchangeably, but in a problem solving, we will insert solubility, and they forgot that solubility also is the concentration, and it will be stated in moles per letter, something like that, and then the students will be lost. Because what we learn is only concentration. They forgot that solubility also is a concentration. That's why the problem solving will be lost sometimes because they will be introducing other terms that we are not used to. Okay? There are a lot of examples for that also. Okay? Sometimes they will use only the general term, but they are referring to the specific term. For example, an amount of a amount of reactant to produce an amount of the product, it's just the same of atoms. Okay, the atoms of the reactant will yield an atoms of the product, something like that. They don't specify the unit. Okay, but that's referring to an amount, something like that. So you need to think, oh my gosh, I like this. And sometimes also, since the students are always using the units, and then they will convert, okay, during the final selection of your answer. For example, if your answer is in terms of dynes, dynes, the unit of force, okay, the unit of force in terms of grams per centimeter per square, equivalent to the Newton, okay? You remember that one, Newton as a force, Newton as a unit of force. And we have also the dyne, equivalent to that by incorporating centimeter in the denominator, okay? In Newton, they are incorporating the meter in the denominator, okay? But it's still a unit of a force, okay? Dyne, D-Y-N-E. And then Newton is, of course, Newton derived from Isaac Newton, right? The unit of a force in the second law of motion, right? Force is equals to M times A, like this, blah, 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 so and so. I touch a little bit with physics, a branch of science, also the study of matter and energy. Okay, like that. So going back to enzymes, okay. Sotero, I like this. Why you connecting the dots? Yes, it's really needed in our discussion also, so that we can properly comprehend and connect that one to understand properly also. Oh, it's gonna be like that. Oh my gosh, ganon. Okay, so I have to illustrate by means of a graphical representation between the relationship of the rate of the reaction and the activation energy. Oh my gosh. But class, we need to remember the two types of reaction, okay, in terms of the environment, okay, not on the in terms of the reaction, but in terms of the environment. We have the two types, okay? Condition of the environment, something like that. Only two. We have the exothermic reaction and the endothermic reaction. Okay, something like that. Okay. Okay. Sorry. Okay. We will be dealing a little bit of thermodynamics here, but I hope it will not. Okay. You've got very enjoyable also, right? Thermodynamics. My gosh. Okay. My gosh. Exothermic reaction. Going back to our high school. Okay. High school education. Okay. Exothermic, because most of the topics in college, the basic foundation are discussed in high school. Then if you are not diligent, resourceful, and you don't have an initiative to go to the library and study, then you will get lost also when you are in the university or institution, because there's a lot of new terms applied already there, and you will be confused. So many items to study well. Then if you have the stock knowledge during your high school regarding basic chemistry, then it's very easy for you to understand clearly in your chemistry subjects in your college education, because most of the college education have basic chemistry, the general chemistry 1 and 2, I think, for all courses in university and institution all over the world have really chemistry, because chemistry is the basic. Okay, it involves a lot. The world we live is a full of chemistry. Okay, everything we see here on earth, okay, from during the time you wake up and then we sleep, all about chemistry. The world, the land, the air, the water, everything, all the reactions around us involves chemistry. That's why it's already incorporated in all subjects in different courses in the curriculum of different universities and institutions all over the world. Something like that. Okay, so going back, exothermic reaction. So Sotero, nakalimot ko sa definition sa exothermic reaction. Charot. Okay, exothermic reaction. My gosh, exothermic reaction. There's a release of heat in the environment. So meaning, if there is a release of heat in the environment, meaning to say the environment is very hot, or there's an increase in temperature. Heat is always be there. Okay, there's a release of it, but in endothermic reaction, the heat is being absorbed or consumed. If the heat or the quantity of heat is being absorbed and consumed, meaning to say the environment is cooled. So technically, the temperature will become lower. Okay, so it becoming cold. So that is endothermic reaction. Now, we try to apply that in the analogy of the enzymes. Here, in my discussion purpose. Okay, I have the graph here. Okay, my gosh. What time is it? 12:22 in the afternoon. Go lang dyan. Shut up. Okay, we have the relationship of the rate of the reaction and the activation energy. Okay, or ROR. Oh my gosh, there's also ROR in economics, right? The rate of return, dealing with interest, principal, interest, and time compounded interest. Like, so I will never use the ROR, right? Because it have the same acronym. I just use ROR, rate of reaction. It's just the same of rate of return. So I'll use another acronym so that it will not be the same. So I'll just put RR. So let's, let's agree, because this is only an acronym to distinguish easily, identify easily, so that we can understand and comprehend easily. So that's the purpose of having the abbreviation and the acronym, in order for us to have a fast and clear understanding, and we don't have to memorize that much. Okay, like that. Okay, RR, rate of reaction. This is the vertical y-axis, arrow pointing at or something like that. Okay, this one. And then we have also the horizontal axis. Okay, the arrow pointing at the right. So this means the activation energy somewhere along here. Okay, and we will represent that one as AE. Okay, thanks to God, there's no another the same definition with AE. Okay, like that. So activation energy. This one. Okay, you can see now the graphical illustration. Okay, like that. This is it. Okay. Oh. Okay, it's very clear. Okay. Now we have the zero at the the center. Always zero here. Huh? Okay, the intersection point between the vertical y-axis and the horizontal x-axis. And now we need to put another arrow going downward. Okay, here. Now this is very important if we learn in trigonometry and algebra. If you can remember the quadrant 1, 2, 3, and 4, because there's a sign. The sign is very important: negative, positive, left and right, downward and upward, something, blah, blah, blah. I don't have to discuss that. This is very common and basic, right? Okay. In going upside, okay, like this, okay, that is energy supply. Okay. If we supplied something, that is an additional, right? Additional. For example, I give you money, so that will be your asset, that money that somebody gave to you. Okay, so that is a positive. Okay, that's why I put that in the arrow positive, in the y vertical axis. That's the analogy and explanation. Okay, and we have the energy released. The energy released, for example, if you release your money to someone, if you give your money to someone, so it has a reduction to your asset. Okay, let's put this in a financial discussion. Okay, so if you give to anybody your money, that's a negative. So that's why I put the energy released in the downward y vertical axis, negative. Okay, energy released, something like that. Okay, energy release. It's gonna be like that: energy supply and energy release. Of course, you will release your energy, or else what will happen if you don't release that energy? So there will be no metabolic cycle in your body if those energy will not be released. Okay, it's driven with kinetic energy. Everything is driven with kinetic energy. All the movement and motion of different substances in and out of our body is always governed with kinetic energy. Remember that one. Okay. Not potential energy, because if potential, it will not move, because that is an energy at rest without motion. Because there's two types: potential energy and kinetic energy. Very important in studying physics. Okay, in motion topic. Okay, energy released. Okay, my gosh. Okay, class, are you listening? Shut up. Okay. Like this. Since I am not inside the laboratory, I don't have any sample and I tested that in the laboratory to prove that it's gonna be like this, the value of this reaction A, reaction B, reaction B. We have to plot one by one versus the activation energy like that. I don't have that data because I'm just plainly talking to everybody, sharing the information and theories. This is not hands-on. Okay, I don't. I'm sorry, my time is already through. I am not inside the laboratory. Okay, so it's good also to vlog and live stream inside the laboratory to discuss properly, right? What's going on in the chemical reactions, right? Okay, if given a chance, given a time to do that, then I will. Okay, like that. So there's gonna be like an assumption only that this is a bit true according to the research that I have. Okay, or basically the study that I have, something like that. It's gonna be a curve. Okay, curve, graph, something like. Oh my goodness. Oh, a graph, curve. So curve. So this is without catalyst first or without enzyme. This is the first situation. First situation without enzyme. Okay. As I mentioned a while ago, without enzyme, there are few reactions. For example, the water. Okay, so it doesn't need catalyst or an enzyme to produce a reaction. Okay, but only very few reversible reactions. Sorry. Okay. Number two, that and we have the activation energy will be here, something like that. This is the activation energy. See? Okay. The only way to prove this one is to do a series of experimentation, okay, in the laboratory so that we can really confirm and really validate this graph, why it become like this. Okay. But since this is already proven as a theory, I'm just explaining to you, sharing this information to you. Okay. Then after this, you can also research, okay, to verify this is gonna be like this, and then correct me if I'm wrong, then I will issue error statement in my description of my video because sometimes I got errors also. It could not be denied. There's no perfection in this world, right? Even though the scientists are not also perfect. Okay, only God is perfect. And we are really committing errors in our discussion sometimes. That's why others doing the scripted vlogs and scripted live streaming, they prepared so that they will be systematic and organized so that we can extend the time. There's a lot of purpose for that. Why they made, the scripted vlogs and scripted live streams. They uploaded in the YT. The first, I think, is to reduce the time length of your videos. Okay, and then to have an organized and systematic way of presenting the content. Okay, and number three, so that they can add creativity in their, videos, animations, in the graphics on the screen, better caption, adding too much colors in the, in their videos, sound effects, visual effects, the impact on the screen, something like they also consider that one. But me, I don't consider that one. I'm purely, really sharing the information. Okay, like that. Okay, this is without enzyme. Number two, this is with enzyme already. Okay. Okay, two situations. Okay, without enzyme and with enzyme. Now we are now with enzyme, meaning lower the activation energy. Okay, lower the AE or the activation energy, something like that. So it has lowered the activation energy. So your activation energy here is gonna be like this already. So small compared to the without. Okay, without enzyme and with enzyme. Okay. The vertical height of your activation energy based in the graph presentation will be smaller in with enzyme compared to the graph vertical distance presentation without the enzyme. Okay, so for example, if the examination in science will state like this, what is the requirement in order for the enzyme to be used in a chemical reaction? So the choices will be, okay, So many choices, and you will choose also lower the activation energy. Okay, because there's a lot also choices. Sometimes you will select all of the above, and sometimes also you will select none of the above. If you think the choices, the correct answers are not there on the question on the answers. Okay, A, B, C, D, like the blah, blah, blah. So, for example, there are a lot of 100 questions for theory. I remember in the board examination, okay, in the second day, okay, in the physical and chemical science subjects, including thermodynamics, I think so. I forgot. Okay, in day one, we have the general engineering examination, as far as I could remember in the board examination. Okay, PRC examination. General engineering is day one examination. Second day is the physical and chemical sciences. There's a lot, and I don't think so. Thermodynamics is under with general engineering. I think number two, thermodynamics is under physical and chemical sciences. Okay, like that. It's there, physics, all types of chemistry, like that. But biology has never been there. But there is biochemical engineering or biochemistry. Okay. Actually, there's chemical engineering. We have the biochemical engineering subject, but not the biochemistry. Okay. But the only difference is I think the application of mathematics, because if we speak about biochemical engineering, there's a lot of application of the figures, numbers, mathematics, and the application of the technology, so that we can easily understand the theories and the principles presented by biochemistry. That's why it's called biochemical engineering. Okay, because engineering usually involves the design aspect of a particular subject. Design, DESIG, it involves technology and the application of mathematics and science. It's always been like that. If we speak about engineering, application of the technology and the application of science and mathematics. That's why in engineering, a lot of mathematics are being discussed there from your first year until your fifth year. And in fact, we have advanced engineering mathematics is being in our course or in any engineering courses, not only for chemical engineering, all types of engineering courses all over the world. Okay, like that. So we have the general engineering in day one. Number two, the physical and chemical sciences or physical and chemical principles, something like that. Okay. Number three is the chemical engineering. Okay. I tell you honestly, I did not expect my highest score is the chemical engineering, really. Okay. And my lowest score is in the general engineering. Oh my God, because I'll tell you consistently, it matched. I don't like really mathematics. Okay, I'm not really that good in mathematics. I admitted it. Okay, that's why I focus mainly on theories, on foundations. But I can acquire the knowledge of mathematics if I kept on practiced solving problems, because I have already the theories and the foundation. So I developed it. Okay, I developed it from year one to year five. But still, it's not really my my strength. Okay, my strength is really science, but since mathematics are applied in science, so I forced to study mathematics. Okay, like that. Okay, not forced, it's linked with science, so no choice, something like that. Okay, so it's gonna be like that. So in general engineering, day one, my lowest score. Okay, and then in day two, my average score, and then the day three examination, which is the chemical engineering, is my highest score. Okay, so it's really echoes that my course, chemical engineering, is my highest score because I have a highest score on my chemical engineering subjects. Okay, supposedly if I am good in mathematics, my general engineering will be high compared to my chemical engineering, but it really matched the result and the output, right? Okay, then you will question also why you don't have a very high score in physical and chemical principles since you love subjects of science like this. Maybe I did not get all the answers of the theories also regarding the questions. Okay, because to tell you honestly, during the board examination, there's a lot of trivia examinations. Trivia meaning we don't encounter that yet. Okay, and then we will just guess. Okay, it's gonna be like this, more closer to this. Maybe that's the time in my score for the day two examination in the physical and chemical principles, something like that. Okay, I remember there's a question there. Really, I never forget this one. Okay, in the day two, the most abundant element in the planet Earth. Okay, and there's a lot of choices. Okay, and then who discovered, hydrogen, something like that. And number three, what is the component of soil? SOIL. Okay, I'm just guessing because as I told you early, I just keep on reading when I was still in high school. Then I make a guess, an educated guess or a hypothesis based on scientific research, and I think I answered it well. Okay, the one who discovered the hydrogen is Henry Cavendish. Okay, the most abundant element in the planet Earth is an oxygen. Okay, like that. And then what's the other question? The most abundant element of the soil is SiO2, silicon dioxide. Okay, that's why it is the raw material in cement manufacturing, CiO2, or the silica content. Okay, something like that. I'm not really sure up to this point in time, but I just answered that one, SiO2. Okay, there's a silicon there, something A, silicon, B, that SiO2, like that. I chose SiO2. Actually, there's also O2. Because I judge that limestone is more on the portion, rock or a stone portion of the soil, then it's impossible that it will become a major component of the soil, right? So I judge immediately that it's gonna be SiO2, silicon dioxide or the silica, because it's not more on the stone part or it's not more on the rock part. Sometimes you will analyze, so it's not that you usually read that one, it's gonna be the answer, the common one's gonna be, you have to sometimes evaluate and analyze, something like that. Luckily, I passed the BS Chemical Engineering examination. Okay, going back to the enzymes. Okay, discussion. So it's very clear now, huh? We have the graphical representation of this enzyme, how it functions and how it behaves so that it can perform effectively. Okay, of course, this is what we're learning. And now, we will now go to the, Sir Sotero, we need to know the factors of how these enzymes behave. Factors, just like, remember your general chemistry, right? During the, what do you call the topic? The equilibria solutions, as far as I can remember, I think equilibria solutions, meaning the reaction, oxidation reaction, reduction reaction, something like blah, 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 so on. And you need to predict like that. You remember that equilibrium of these products K and then reactants K, and then you have to compute the factors for that affecting the equilibria solution. It's gonna be the nature of the solute, as far as I could remember, the nature of the solvent, okay, the temperature and the concentration, and I think even the catalyst. I'm not sure with the catalyst because in the definition, catalyst will never consume and will never use through the entire process of chemical reaction. It's been applied because for the purpose of speeding up the rate of chemical reaction only. Meaning to say, if the catalyst, for example, is 1 gram in the initial stage of a chemical reaction, then after chemical reaction, still 1 gram of that catalyst. It will never change the amount after or the entire process of the chemical reaction. Something like that. That is a catalyst. So I don't need the equilibrium solution or what we mean as the solubility. Okay, factors affecting solubility are nature of the solute, nature of the solvent, the concentration, the temperature, but I'm not really sure for the catalyst. Okay, help me research that also in your general chemistry because I really forgot. But I think it's only 4. Catalysts are not included there. In the benefit of a doubt, I just include that one. Okay, but because that was 20 years ago in my, in my BS Chemical Engineering course. Okay, maybe I will forgot that one. Okay, so it's the same thing also in enzymes. Factors that affecting the enzyme activity. We have also the pH, the concentration, the temperature, sorry, and the inhibitor. Okay, inhibitor. That is inhibitor. Inhibitor is the reverse for the catalyst. So meaning it decreases the rate of the reaction or lowers the rate of the chemical reaction. Okay, this is inhibitor. For example, if there is good, there's also bad. Okay, like that is antonym, meaning the opposite of the other thing. Okay, war, peace, like that. Okay, good, bad, something like that. Rich, poor. This one is catalyst inhibitor. This is opposite antonym. Okay, words have different meaning. Okay, in opposite meaning, something like that, okay? Because we have homonyms, antonyms, and synonyms, right? Okay, in English grammar. Okay, so we need to have the inhibitor. Okay, now I'll show you pH. Oh my gosh. I think it's also per. It's always an assumption based on my research. I wish I could work back in the laboratory also. Since 2000, I worked in the laboratory also. Okay, in Coca-Cola Butlers, Philippines, Tagbilaran, Bohol. Okay, I am a product engineer in the laboratory. Okay, the quality assurance department. So I wish I could back to work there. It's enjoyable, right? There's a lot of chemical tests like that, blah blah blah, so and so. Okay, never mind. Okay, we need to go back. pH, the RR again. RR, rate of the reactions I told you earlier, right? Okay. And then arrow up, vertical y-axis, and then horizontal axis. Oh my gosh, the x-axis is our pH. So Sotero, what is pH? As far as I could remember, that is the measure of the acidity and the basicity of a substance. In our high school years, if the blue litmus paper changed to red litmus paper, that is an acid. If the red litmus paper will change to blue litmus paper, that is a base. That's it. That's only an identification visually in our high school, okay, chemistry. But in college, there's a lot of identification for that. Not only the litmus paper, okay, through, quantitative and qualitative chemistry test. And we have also the spectrophotometry tests by means of a light radiation. Then you can present the sample, and then we can test that through spectrophotometer, something like that. And by the presence of the light, it will detect that this substance is really an advanced test in, I think, in qualitative chemistry. Amount you have to predict what type of element or substance are present, like that's qualitative. On the quantitative chemistry, that's more on what amount or how much amount of substance are present. So more on the stoichiometric amount relationship. Okay, so it's in there that we will apply the chemical calculations, okay, or the stoichiometry relationship to solve for the amounts of the reactants, the products, or raw materials, like that. It's in the quantitative chemistry. But in the qualitative chemistry, we're already focusing on the what amount are present. For example, you are given a sample like this. Your instructor will try to put that in the, for example, right? Graduated cylinder, okay, or a flask. They put a chemical substances there, and then you try to test what is the name of that compound or what is the name of that element, and you have to measure and test that in the laboratory. Quantitative chemistry more on the amounts. For example, if your chemistry instructor will put a chemical substance there in a flask or in a graduated cylinder, you have to determine how much is the amount being present there that the instructor put, and you will have to undergo a series of laboratory tests to determine the exact amount of those substances that your instructor put into it, something like that. So that is quantitative chemistry. Okay, so there's a difference. Okay, like that. So going back to the relationship, let's go directly. The curve will be like this. Okay, still the same like this. Okay. Okay, this is gonna be the relationship with the rate of the reaction and the pH. Normally, the pH of the enzymes, it is in the range of 6 to 8, meaning to say partly acidic and partly basic, but the basic part is not so high. If you can remember, 1 to 6 is acidic, right? And 8 to 14 is basic, and the neutral is 7. So if we mean 6, that is still acidic, right? If we mean 8, it's still basic in the lower part. Okay? So that's really the range of the pH of an enzyme. Okay, but not all, but majority, something like that, based on the study conducted of those biologists, chemists, or scientists before, especially majoring biotechnology, biochemical engineering, like this, in the laboratory, something like that. Okay, And the third one will be the relationship of the rate of the reaction and the temperature. Okay. I must discuss this because our enzymes will not behave and function properly if we don't have this relationship. Okay. That's the purpose behind. Okay. Rate of the reaction on the vertical axis and the temperature in the horizontal axis. So the graph will be like this, diagonal, escalating linear line. Okay. Meaning, as the temperature increases also, the rate of the reaction also increases. Okay. Why? Just tell why. Let's put that in this way. For example, we have the water molecule. Okay, we need to take the coffee. Okay, we put water in our kettle and we heat that one. Okay, and it reaches the boiling point, right? When it reaches the boiling point, meaning the vapor pressure of the liquid equals to the pressure of the surrounding or the environment. So that's the definition of boiling point. Now, and there's a bubble inside. If you look at it visually inside the kettle, and the vapor will escape to the atmosphere or okay, something like that. So there's a lot of energy applied there because the amount of the liquid goes downward. Okay, so the volume decreases. Okay, the volume decreases as you heat that continuously. Okay, so and then there's a lot of kinetic energy there. Okay, the more too much kinetic energy there, and then the more the volume is become lowered. Okay, then there's a lot of collision of the molecules. So the intermolecular forces of the molecules between the gas and the liquid, okay, inside the kettle, they will move too much and bombarded with each other. So the more the kinetic energy will rise, okay, the more the volume will become lower, the more the temperature will become higher, okay, and the rate of reaction is becoming high. So that's common sense. The reaction, like just like us, if it's very hot, then we will not feel cold. We will react, we will complain that we need an AC, something like that also. So we need to have the rate of the reaction, but our rate of reaction is not chemical in nature, but it's a complaint reaction that we need an AC because it's very hot. Something like that also, the same analogy with this principles of rate of reaction with the enzyme. So the more the temperature rises, okay, there's a lot of kinetic energy and there's a lot of intermolecular forces, and the molecules are bombarded with each other, collided with each other. The volume will become lesser, okay, and the pressure will get high, okay. Too much pressure, of course, because the surface area will become low, okay. The more the volume will go down, the area also will become low, okay, because there's not too much area for that, okay, like that. So in the formula, pressure is supposed to force over area. Remember that one also, okay? The area we mean there is that surface area of the kettle, okay? And the area also of the water cover during the lowering of the volume of the content of the water area, okay? The space, shall we say, okay? And the pressure there. So meaning to say, if the area will be lower, the pressure will be high. Through the relationship mathematically, pressure is equals to force over area. Through that formula, we can determine the relationship of the behavior of those physical property of this pressure, of this force, of this area. The same with this rate of reaction and the temperature. So normally, if we heat the water, there's too much rate of reaction. If we heat that very, very fast or heat that at a higher temperature, the more the boiling point will become fast. Something that if you heat that very fast, okay, in a very high volume, okay? For example, 1, 2, 3, 4, 5, and you make 5. So it's easily heated up, okay? So there's a lot of kinetic energy there. Okay, and the reaction is very fast, like strong, like that, and the molecules will be colliding with each other. There's a lot of pressure, blah blah blah. So and so, it's just like this. That's how we come up with this relationship. The rate of the reaction will always increase if we increase also the temperature, something like that. Okay, so that's gonna be a normal process of an enzyme characteristic and behavior. Okay, so we need also to remember the basic formulas in chemistry and physics in order we can derive our analysis for the discussion also. Okay, now we go to the rate of the reaction and the concentration. Okay, oh my God, what is the graph for this? Okay, so I'm tired of making a graph because my pencil pen is almost consumed. Oh my gosh, it's happening. Okay, so I'll just state this in this way. If we have a higher concentration, okay, then the rate of a reaction, what will happen? Okay, something the relationship. Okay, so if you have the rate of the reaction, and the rate reaction will also be complementary for that concentration. Okay, like that. Okay, complementary meaning they have a relationship with each other, directly proportional with each other, something like that. Okay, because if the rate of reaction, because class, the rate of reaction will always cover time or period. That's why it is. For example, letters per second, something like that, or whatever. There's always the time in the denominator. Time could be seconds, like that. Okay, moles per second, moles per hour. For example, we have BTO per hour, British thermal unit. Okay, per hour, something like that. So we have a time in the denominator. So those are rate of reaction. That's why it become a rate. Okay, so usually if it is higher, the concentration is higher, it's also having a equivalent high of the rate of reaction, so like that. Okay, so directly proportional. Correct me if I'm wrong. Like it was discussed properly in the reaction kinetics or in the chemical reaction engineering, one of the subjects in chemical engineering. It's being discussed how to deal with a nuclear reactor, okay, then a nuclear power plant. Okay, the basic there are the chemical reaction engineering. Okay, nuclear power plant. Okay, the principle used there is the nuclear chemistry. So usually using the principle of chemical reaction engineering or reaction kinetics. Kinetic, right? Because that's movement or motion of the particles or atoms. The electrons, the protons, the neutrons, the positrons, the photons, that. And it's in there also you will understand the enthalpy, the entropy, something like that. Okay, that's also covered by physical chemistry. Then you will also study that one there in combination with the chemical reaction kinetics. Okay, something like that's why I think so. Physical chemistry is the prerequisite of chemical reaction engineering subject. I don't know, I forgot. Because we need to also to understand the physical behavior of various elements and substances. The physical behavior, physical characteristics are being discussed in the physical chemistry. All about physical state, for example, boiling point, melting point, heat of vaporization, evaporative cooling, okay, surface tension, viscosity, diffusion, thermal conductivity, something like that. Okay? The temperature, the pressure, blah, 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 so the freezing point, something like that, okay, or the qualitative properties of different substances are being discussed there. What else? So many things, right? The physical properties, okay? The boiling point, like blah, 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 so the density, okay? The specific gravity with in relationship to the temperature, okay? With equivalent temperature. So all are discussed there in the physical chemistry. Phychem. We abbreviate that one as phychem. I think that is prerequisite for chemical reaction engineering study, subject in chemical engineering, because there we understand really, okay, the behavior of all the atoms, the cells, and the molecules, blah, 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 so and so. Sometimes you will be crazy. What do you call this one? Your brain will be stressed. Charot. Okay, so this is very purely imagination. It's very hard to study if you don't see in actual what's going on, right? Because we don't really see what this positron all about, the proton all about. We cannot see in our naked eye. Okay, we can just only see that through a microscope, microscopic technology, okay, through any advanced technology, and we can see that in our screen on the computer. But I cannot see electrons here. Okay, I cannot see protons. That's the difficult in our course in chemical engineering. We cannot purely imaginations also. Okay, unlike others, they can really see what they are doing. Okay, you can see the machine, they can see the equipment, they can see the electrical items, they can see the electrical devices. They can really see in their naked eye. But chemical engineers, they can never see everything, what's going on, especially the enzymes. I cannot see the enzymes in my eyes. Okay, but we can only detect this in the laboratory through the aid of technologies. It's very difficult, really. And you have to study the behavior, the properties, the principles behind something like that. Okay, that's the difference only with other engineering courses. Okay, sometimes, as far as I could remember, there's a lot of students in our first year engineering, and then after second year, a lot of students shifted to another course. And then when we graduated, we are at least about 20 out of, let's say, 100, something, because they shifted another course, because sometimes we cannot understand really me. Okay, very, not really that very difficult that much, but we are confused, and sometimes it will add stress to our brain. Okay, brain, our brain capability, and oh my God, what's this? Especially when you encounter a lot of terms such as van der Waals equation. Like, oh my gosh, what's this? It talks about molecules. Oh my gosh, I'm using this formula. And then sometimes the formula is not really that exact. Then you have also to derive a new formula. So, oh my gosh, especially me in day 3, the chemical engineering, okay? There's a question there out of 70. Oh my gosh, I don't know really the formula for that exact question. And then I use my own formula just to achieve that question, remember? And connect like this. And it took me a long time to solve that problem, only one problem. Okay? Oh my gosh, I don't really encounter this in my subjects. So I make a lot of correlation on the spot there. I use a lot of formula there. I connect that there. And thanks God, I make a one derived formula, and I insert that as given there. And the answer is very close to the choices. Okay, and then I answered that there. And I don't know if it's correct or not. Because after the examination, they don't tell that the answers are correct, right? You just know that you passed that examination, something like that. You don't know really if that number 1 is correct, number 2 is correct. They don't return back your papers after the examination. And you cannot justify if you are wrong or correct. All you have to do, oh my God, something like that. And as far as I could remember, I was one of those examinees that going out from the room last. Okay, others are going out already, but I'm still inside the examination room because really I have to make a buhis buhay on the last part of my study in chemical engineering, and I have to, shall I say, it doesn't mean this true. I have to prove something also. Okay, something because it's in our genes that we are really good, something like that. Academically, then I have to prove something like that. Then it really matches the result. Thank God I passed the chemical engineering board examination. Okay, something like that. And my point is, it's very difficult in the 3rd day, really. And thanks God also, that was my highest score, the chemical engineering. Okay, thank you so much. Lord God, thank you so much. Okay, that's going back to the enzymes reaction. Okay, that's it, right? The factors. And go back to the examples for another enzymes in the digestive system. Okay, before going further for this digestive system enzymes class, we need to categorize. Okay, what are the parts of a digestive system? As far as we know in our science, in elementary, I think so. In elementary, right, it's being discussed there, the heart, the brain, but not in a complicated manner or not in a complex manner. But our teachers in elementary are discussing the basic parts and the functions. I think so. They don't deal with the disease controls and the disease prevention and what types of disease will be occurring, but they discuss the parts by parts and the functions in a easy to understand manner because that was our elementary education. We are very young at the time, right? We are a child. So how come we will absorbing difficult, information? Our brain is not just, it's not thinking properly, very in-depth understanding of different subjects. Okay, we have that in our elementary, right? In our science, okay, the brain, the heart, the blah blah blah, so and so. It's being discussed there also. Okay, like digestive system composed of the pancreas, the intestines, the salivary gland, like that, and the gastric gland. That's why we have gastrointestinal abdominal pain, like that. We feel that in our stomach, especially if we eat full overconsumption of this food. For example, you eat too much ice cream, like that, or too much, shall I say, cake, and then you feel something bad with your stomach, like that. And you drink a lot of water, something like that, and you'll take paracetamol to remove the pain in your abdominal, like that. So that is gastric, okay, gland, okay. So that's the parts. So that part, each part have its enzyme. Oh my gosh, to produce those products that are necessary for us to become healthy. Okay, or in order necessary for us to move or to achieve energy properly. You can walk properly. Okay, you can work properly. You can walk properly. Okay, you can hear properly. You can speak properly, and you can do your routine work properly. Something like that. We need these enzymes to control and regulate this various biological substances found inside and outside our digestive system. And the enzymes are responsible for that. Okay, now we go first to the intestines or the intestinal gland. Okay, we have four. Okay, I will write. My gosh. Oh yeah, my papers are almost consumed all. What will I do now? Charot! Talaga. Okay. We have the four enzymes in our intestines. Remember, this is very important, okay? Okay. We have the lactase. Okay, guys. The clue there, if it ends in ASE, that is an enzyme. ASE. For example, amylase, okay, pectinase, oxidative, isomerase, protease, lipase, ligase. So those are enzymes because the three letters are A, S, E, so that we can really identify. For example, an examination also, the question stated there, there's a lot of R proteins, R enzyme. For example, which of the following is an enzyme? Choices will be like this: A, aspartic acid; B, glutamine; C, lanolin; D, lactase. So your answer will be lactase because it ends with ASE. Okay? That's already a technique. You don't have to memorize anything, only the ASE. Okay? And you don't have to formulate the chemical structure, whatever. So that's only your clue. Okay? Automatically, without question, ASE. But the saddest part, saddest talaga, but the sad part, sometimes also, there's still few only, not that much. There are also enzymes that does not end with ASE. In the case of enzymes that contains RNA, catalytic substances, RNA, ribonucleic acid. Okay, if we have the deoxyribonucleic acid, which is the DNA, in the nucleic acid sequencing, we have also the RNA, ribonucleic acid, meaning the ribose sugars are responsible for the synthesis of this RNA, so that this is essential for the genetic information, coding of genetic information of our hereditary traits or inheritance. So that is or our offsprings, something like that. So that's very important also, okay, in a genetic study, okay, genetic, okay. So ASE is the enzyme, okay. Lactase, number two, sucrase. I already discussed sucrase yesterday, right? Okay, I will never choose sucrase anymore because I discussed this yesterday. Okay. Okay. Number three, maltase. Charot. May ganon. Maltase. Number four, lipase. Charot. Okay. These are the enzymes found in our intestines or intestine gland, in our large intestine and small intestine. These are very, very important so that it can produce the products of digestion. Okay, the products, very important really in our metabolic cycle. Okay, like this. So these are the enzymes. Okay. Now, lactase. So what will be the products of lactase? Okay, so the clue there is lactose. It's very close, right? You think lactose immediately. So our substrate will be the lactose. Okay, lactose. In enzymology, really, class, uh, we need to familiarize the substrate, the enzyme, and the products only. Okay, not really that much with the factors affecting. You are only given with only an information, an idea that's gonna be the behavior or the function if we will change all those factors, which it could affect. But the basic discussion will focus mainly to the determination and identification of the enzymes, substrates, and the products, something like that. Here in the lactase, our substrate will be the lactose, and the products are okay, glucose, sarap, and galactose. Oh my gosh, galactose. Now, in the first item number one on lactase, we eat everyday rice, right? We eat everyday bread or whatever. Technically, we are producing glucose in our body. Okay, glucose in order to give us energy. Okay, this is really the main source of energy, glucose. Okay, like that. Now, this is coming from the lactose, and the lactose will not speed up the rate of reaction without the lactase. So how important the enzyme really is. Okay, because it will never give this sugar product if there's no enzyme lactase. Okay, so just like you are, for example, you work. Okay, if there's no computer, if there's no tools, if there's no materials or any equipment that will help you to succeed in your work or to complete your task, then there will be no output in your work. It's just the same also for this lactose. Okay, so this lactase will have a job to speed up the reaction so that to produce the output or the results, glucose and galactose. And we need this glucose in an adequate level in our body to be healthy. Okay, because without glucose we cannot survive, we will automatically die. Okay, I mean if we have a zero glucose in our body, zero, okay, we'll die, no question, technically. Okay, like that. So because this is the main source of energy, that's why we have glycogen. Okay, glycogen, the stored area of all those glucoses or sugars in our body. That's why we need to burn that out also, because if it is overstuck there, then it can cause hyperglycemia, type 2 diabetes, overweight, obesity, and your stomach will become bulge like that, and you cannot walk easily, and you like that, your inhalation will be obstructed, something like that, and your blood flow circulation will be affected if you have high levels of glucose in your body, inside your internal system, something like that, okay? Sucrase is the enzyme. Our substrate will be the sucrose. Okay, sucrose. And it will produce the products of digestion, which is the glucose and the fructose. Oh my gosh. And the fructose. Fructose is the sugar chemically found in citrus fruits, right? Okay. And glucose is a sugar technically found in the bloodstream. Okay, so that we can have a good regulation of our bloodstream, and so that we can breathe properly. There's a good blood flow circulation, and then we can regulate properly the levels of our insulin hormone and the glucagon hormone. Glucagon hormone relationship in the insulin hormone. So there are the two hormones that are really necessary, complementing with each other to regulate the adequate level of blood sugar in our bloodstream in order for us to survive being healthy all the time. Because if the blood glucose will not be regulated properly in adequate level, then you will develop a type 2 diabetes and you need to insert more insulin. Okay, and insulin is very expensive nowadays. Okay, problem for type 2 diabetes. That's why we need to control the glucose intake and control the rice intake in our body. Okay, because there's still a lot of sugars there, not only the glucose, fructose, galactose, blah, 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 so and so, ribose. So what will happen to our sugars inside our system? That's why we need to have metabolism cycle or metabolic cycle to release that or to expel that from our body. Okay, we need to use our reserve sugars in the first place. Okay, that's why we need to do sometimes ketogenic diets or ketosis or exercises or workouts sometimes once in a while or to do physical activities to remove sweat from our body. It's not enough. We should be really having that sweat as WAT because that's an identification technically and visually that some fats are digested, some toxins, non-identifiable toxins are being released there in our systems, from our system, sorry. Okay, like that. So that is so cruise. Okay. This is inside our system in a physiological reaction because we have also sucrose coming from the market. Okay, that is carbon 12 H22O11. That is the refined sugar, the white color, right? It's a processed sugar that is still sucrose, and we also, break down this glucose and fructose. What I'm pointing here is there's a natural way and there's is an artificial way also. The natural way is inside our body, which is the sucrose will convert naturally with glucose and fructose. But if we buy that on the market, that is an artificial process of producing glucose and fructose, and then we put that in our coffee. Okay, we stir the coffee, right, and put the white sugar, and it will go to our body. So that is artificial way of converting sucrose to glucose and fructose because that is not inside our body. Okay, that is artificial way. Okay, what I mean with natural way, it's already inside our system and we let our hormones, our enzymes, and biological substances to work by themselves. That is natural process. Okay, like that. So that's why we don't need to buy all the time white sugar because we are having sucrose already inside the body. Okay, you get the point? Because we can also get this sucrose from the fruits, from the plants, from the carbohydrates, not necessarily the white sugar we have in the market. Okay? Okay, number 3, maltase. Maltase. That's the reason why I don't put white sugar in my coffee. Really, it's really bitter, bitter. But I sacrificed that because of my weight loss program and some health benefits also. Because I read a lot, if you put white sugar, then the nutrients and vitamins will not function effectively inside your body. Okay, you can also put a little bit only. That will be okay because there are a lot of people also don't love the taste bitter. Bitter. Who among us loves bitter? No, it's always sweet taste we like most of the time, and sweet is the very very popular taste all over the world. We love that one in our taste buds. Usually, all over the world, children love sweets. And also, adults love sweets. Okay, that's why. So that's why they put sugar, white sugar in their coffee or in the cake, whatever. Okay, in producing, for example, banana cake. Okay, or any pastries related food, cookies like that, halo ice cream, like the chocolates. Okay, have white sugar incorporated with that. That's why we need to evaluate also there. As I said this earlier, the nutritional facts in the packaging of the food you buy, something like that. Try to examine the added sugar. Always, there is added sugar. Take note of that one. If there's an added sugar, of course, white sugar or sucrose, carbon 12 H22O11, or the processed sugar are being incorporated and added with that particular products. Be careful. But there is also products don't have added sugar. Good. Okay, but that relies only for the natural sugars you can obtain. For example, strawberry, jam, something like that. The sugar there is only the sugar coming from the strawberry, which are the fructose. And no need to add sugar because they're already sweet. Okay, so that's like that principle. Okay, you have to evaluate the nutritional facts of all the products you buy in the market because it also affects our, the condition of our health. Okay, maltase. So maltase, this is our enzyme, and our substrate will be maltose. Okay, my gosh, Maltose. Okay. Maltose, by the way, class, is a sugar found in fermentation industry, meaning the production of beer, the production of wine, the production of beverages. The sugars incorporated there are maltose. Okay, like that. And the lactose are in the milk, something like that. Okay. This maltose really is for the fermentation industry. Okay. And the enzymes there are maltase. Okay, this is sorry for the production of the glucose. Oh my gosh, nakakaluka. Okay, dalawang glucose siya. One monomer of glucose plus one monomer of glucose. Oh my gosh, so in mathematics, glucose raised to the power 2. Charot. Okay. If we put this in algebra, right? Okay, in the context of algebra. Okay, so maltose is equals to glucose plus glucose, but our enzymes here are the maltase. Okay, like that. Okay, through this definition or the breakdown of the substances, we can understand really what is the substrate, what is the enzyme, what are the products like that. Lipase. Okay. Glucose, well, to stress this something. Okay. In the production of beer, you love wine, right? There are a lot of people love wine, especially Christian people loves to drink alcoholic beverages. Not all, but majority. I think 70% up. Okay, drink wine, alcohol. Okay, beverages, beer, like that. Okay, it depends on the culture, the tradition, the personality type, and the behavior of any individual. Okay, it depends on the person really. How he or she grow up in a family. For example, if their family are keep on drinking alcoholic when you are still 2 years old, you always watch them. Then when you grow also, you will also learn how to drink because that's what your parents are doing. So that's what I mean with the culture. Okay, and then the genetics also. Your family history will drink, and there's a great possibility that you will also drink. Okay, like that. But in my case, I will never drink. Okay, alcoholic beverages. Okay, something like, even though my father will drink and my brother will drink and the husbands of my nieces will drink also. So I'm not the one who drink, something like that. So it depends on the situation, really, your culture, your behavior and personality, your perception in life, your character, your behavior, something like that. Okay. Okay. So this maltose, glucose, whatever. So it produces a lot of glucose in your system. Okay. And then plus the glucose you intake every day, the rise. What will happen? Too much glucose. So when you reach the age of 50 to 60 years old, what will happen? If it will accumulate, okay, it will increase the levels of your triglycerides, okay, above 150 milligrams per deciliters in your medical exam results. Now, if high level of triglycerides, it is complementary to the cholesterol level. So your cholesterol level will become high. At the same time, directly proportional, your sugar also will be high because, of course, the glucose is sugar. Okay, something like that. And you will develop obesity, like cardiovascular diseases, or it could be cirrhosis, inflammation of the liver, okay, the liver cancer, the fatty alcoholic disease of the liver, okay, something like that. If you have too much drink excessively, this beer, wine, whiskey, and gin, because this contains maltose that break down into glucoses, still sugar. Okay, like that. And also your glycerol level will increase. So Sotero, what is glycerol? Meaning the sugar alcohol in your body. Okay? That's why it's named as glycerol. Glyceraldehyde, coming from the glyceraldehyde. Okay, 3 carbon atoms. Okay, like that. It's gonna be like that, huh? Okay, so this glucose. So we need to regulate this in our system by a healthy lifestyle, of course, and we will connect that to the enzyme. Okay. If we adjust something, the enzyme also will be adjusted automatically. So meaning to say, through our actions, everything will be adjusted inside our physiological reactions inside our body also. Okay? It's very clear, right? Because, for example, if I will eat this chicken nugget too much, then of course, there's a lot of chicken nuggets that will go in my system. Now, we remember in health science, if too much saturated fats, since in the first place, chicken nuggets, burgers, beef burgers are all saturated fats. if so many saturated fats, what will happen to your heart? Okay, the left arteries, the arteries will be hardened, and the blood will be clogged or coagulated, meaning it become a thick, solid coagulation of your blood. It will clog in the endothelmia, in the inner layer of your blood vessels. Then your tissues will be damaged. Heart attack known as myocardial infarction. Okay, myocardial infarction is the heart attack. And if the blood vessels will go to the brain, then there's a clogging there of the blood, and the cholesterol will be deposited. That is, okay, cerebral infarction. Okay, that's the medical terms of each. Again, head stroke is cerebral infarction. Heart attack is myocardial infarction. Okay, so at least we know a little bit of medical terms. That is based on my research. Okay. Going back to this maltose, lipase, that's all will be governed by good healthy lifestyle for that, so that we can prevent that one from coming as we reach 60 years old, early or young, then we do it. Okay, we need to prevent. Okay, lipase, our enzyme will be lipase, our substrate will be actually lipid, right? But in some of the reference books I encountered, really, okay, when I read research like that, most of my times I'll keep on researching after the work. Okay, that's why I'm keep inside in the room. Okay, I'll never go to outside like blah blah blah, except for my regular exercise and the cricket oval. Okay, and do vlogging and live stream. I'll never go out most of the times because I do research a lot, reading, watching videos. Okay, informational topics, something like that. Okay, so like this, lipase. Actually, the substrate is lipid, but it's eating with fats. Because fats, lipid category is a fat also. Okay, so that's why they use the term fats. Our substrate will be the fats, and our products of digestion will be glycerol. Oh, there it goes. Glycerol and fatty acids. Wow, I love fatty acids. Omega-3 fatty acids. My gosh. Okay. I don't have to discuss omega fatty acid, blah, 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 so and so, because this is only enzyme topic. Glycerol plus fatty acids. Okay. Oh, this one. This is coming from the intestine gland. I don't think so. I have to discuss everything regarding the digestive system. I'm already how many hours now? Oh my gosh, 1 hour and 47 minutes. Let's go now to the pancreas. Okay, pancreatic gland. Charot. Okay. The pancreas also are responsible for the good regulation of our insulin hormone, glucagon hormone, and the blood glucose level also. Okay, like this. Okay, wait for a while ha. Naubos na yung mga papel-papel ko, in fairness. Too much writing. Oh my gosh. Pancreas. Oh my gosh. This is where the enzyme that does not end in ASE will be appearing. Okay? Like that. Okay? Charot. Oy, naubos yung papel ko. Goodness. Charot. Talaga? Oh. Really? Wait for a while, mga kapatid. Wait. Ano ito nangyari dito? A lot of scratch papers. Oh my God! Ano nangyari? Wait, ha? Here. Okay. I have to segregate first the papers, the scratch papers. I need to conserve resources before throwing in the trash. Okay. Segregate properly as one of the requirements of environmental waste management. Charot. Reduction of wastes from the source is very important. And then we need to avoid throwing anywhere our wastes because it will pollute our environment, specifically in the land. Like that. Okay. So like this. Oh my gosh. So many scratch papers. Okay. Hello guys. Thanks for watching. Mr. Ramon Jr. Ambongan. Oh my gosh. Thank you so much for coming in my live streaming. Okay. So I will. Oh my gosh. How can I go? Okay. Hello, sir. Oh my gosh. Hello, sir. Have a nice day. Ganon. Okay. Oh, somebody interacted with me in my chat screen. Okay. Like that. Okay. Guys, I can't sing because the voice quality I have so cracky. Yesterday I tried to sing and my voice was cracked, even at a low note. I don't know why, because I think this is for the lack of sleep sometimes. Okay. And then I drink also cold water sometimes. Okay, that's why. I break my protocol. Prior to my singing moment, I will never drink cold water and I will never eat sweet foods to alter the voice quality, right? You will never eat salty food. Yes, I ate salty food a while ago. Okay, I cooked small fish bulinaw. And I eat that bulinaw. And then it will alter the voice quality really. Salty food, sweetie food, and cold drinks will alter your voice quality. So do not intake that when you do the singing moment. Unless you are drunk or drinking alcohol. Because those people will never mind that their voice quality will be cracked because of the alcohol strength. Okay? You keep on singing and never mind the voice quality because technically they don't mind as long as they are happy, then that's it. Okay. But for me, I always, I'm very particular for that as my self-discipline. Okay. I never drink cold water, eat salty foods, and eat sweetie foods prior to my singing moment. Could it be live or not live? Whether could it be on Facebook, YouTube, something like that. Okay. You can also ask other singers. It's gonna be fake. Okay. Including the sleep, if you have lack of sleep, the muscles of your vocal larynx here in the throat will be affected also. Some of the tissues and muscles, when you sing, you could not deliver a very good vocal performance if you have a lack of sleep. Okay. That's why because your voice muscles and tissues will shrink or will compress if in a too much cold environment. Okay, that's the reason technically. Okay, it does not mean that I off the AC so that my voice will be heard by other people. No, it's not like that. I off the AC because it's very cold and my voice quality will compress and shrink because it's very cold. Okay, again, it's science. The more the environment will be cold, the more it will be undergoing a compression action. Okay, just like in a refrigeration principle, right? Your fridge. Okay, so that's your voice. Nobody wants or shrink, right? It's just the same like that. That's why I off the AC when I sing. Okay, but I think also with the individual resistance also. I think it's just I cannot survive with too much cold. Okay, when I sing. Okay, like this. Plus the title foods like this. Though I'm not a recording artist, but I have that discipline. Okay. Because I always sing songs that requires belting of high notes. Then I cannot reach the high notes, and I cannot belt it out perfectly also if my voice will just crack somewhere along the way, right? So that's technically the reason. And it will sound so cracky. You know cracky? Crack. Like that. Okay. So sorry for that. I cannot sing. Okay. Okay. Sorry, guys. Anyway, I have heard songs. Church. Oh yeah, flashcards. I have to play that one. Okay. Oh my gosh, too much scratch papers. Oh, what's happening? Hala reaction. Oh, what's happening? Hala reaction. Time check go to the powdered Alaska. 9643. Tower up. I will try singing one song. Let's say if my voice is good or not. My gosh. My goodness. Sa bawat pag-ikot ng ating buhay, may oras ay kailangan maghiwalay. Puso'y lumaban at walang magagawa saan ka. Ay, ka muling mahalan, magkulang sa atin. Ako na tayo'y magkikita muli hanggat may umaga pa na harapin. Ikaw lang ang mamali. See, cracked. My voice is really cracked, right? I told you I cannot sing properly at this point in time. Mamali. I cannot reach the pure voice in the end. Sorry. I can still be able to use falsetto, but you know, I can still, it's not really that appropriate for me to use all the time falsetto, right? Like that. Diba? Sibukan ko talaga siya. Dinarap talaga siya somewhere in the end. Sibukan ko. Hanggang umaga pa na mahali. Vibrato. Ganon, that's vibrato. Ganon. Vibrato or resonance in singing. Artificial voice. Okay. Hindi naman babaan ka siya. But I'll just, you know, I will not just be challenged if I will start too much in alone. Okay? Parang, you know, my world will not be satisfied if I cannot belt out high notes somewhere in my vocal performances. So that's the logic behind my singing moment. Because I really, you know, ability. Top singer. Charot! Talaga. Pop talaga. Meaning ballad. I was singing a ballad. That also requires somewhere in the bridge part of the song having a high note, right? Most of the times. Okay? But not all the time. Okay. My gosh. Oh, ito na pala yun. Okay. Tapos na. Wala na akong scratch. Papers. Hello guys. Okay. Ito na. Time check is brought to you by Power. Last one. 9643. Your connection is unstable. Please wait while we try to reconnect it. Oh my gosh. May instruction pala siya. Charot. So I'll just pause for a while waiting. My connection will be stable because the instruction in the screen is your connection is unstable. Please wait while we try reconnecting. Something like that. Okay, so I need to pause for a while. So, nagano talaga? Yes. Talaga. Hello guys! Ganun. Okay. Talaga. Bakit may ganun? May something ba yun? Wait for a while ha. Ay naku. Okay. Sorry for that guys. Okay. Oh. Bakit stable siya? So, guys, if you think this video, then you're able to share it to anybody else if you want to. Click the notification bell for some update. I am a senior internal voice, and then you can comment, of course, in the comment section. Thank you so much. God bless everybody. See you later. Have a good day.